My name is Dr. Tyler Tolbert.
And I'm Dr. Soren Poppy.
And you're listening to The Fix Podcast.
Well, yeah, and correct me if I'm wrong, Tyler, but Tyler and I were with, luckily, earlier this year, or I guess last year, we're in 26 now, but we were with Dr. Tomei, correct? Is that how you pronounce it? And that was a question I asked for it, was, when do you use your Aqua implant? And his answer was, just like you said, patients that he thinks that healing is going to be inadequate, or maybe not inadequate, but not to the standard of like a very healthy patient, uncontrolled diabetics, patients that are smoking. Maybe if there is an indication for a patient who has had bisphosphonate therapy and you're we're either doing this and you understand the risks, or we're not going to do it.
Yeah.
That's the time to use these implants, is when maybe you're uncertain on that healing. That's where, maybe you spend a couple extra bucks to place an implant with that extra coating, because we're going to throw everything at the board and see what sticks.
Yeah. And the even easier answer for me, I would put it in everybody. I mean, right. It's my practice. I want it to work. If I got to pay a couple extra bucks for something that's going to work better. I mean, you look at the spectrum of pricing with implants today, right? And man, we're in a great spot, I think, across every company out there, all these different 80-some plus companies, right? And then the other thing is, I don't have to worry about pricing. So you guys can talk to your rep. Yeah, but give me your thing and help me be more successful, right? It's the practice of medicine. It's not the law of medicine. So,
right. Yeah. Talking about, back to like grade 4 titanium and that, what are your thoughts on zirconia implants? And
I thought about that earlier. I didn't know if we wanted to bridge into it, but it's a good question.
NeoDent has one, and Straumann, I believe, does as well. Correct? Do they have two separate ones? But when do you see clinicians using those? Do you like them? Do you see higher fracture rates?
Can I use it in full arch? Is a big question.
Yeah.
Right away. No.
Good enough. Didn't think so. Yeah.
Can't tell you how many calls I've gotten already. Right? Somebody allergic titanium. Some people thrown them in, didn't realize indications. And I was like, man, let's try and get through this. Let's get a solution. Right. So, so no, not indicated yet. Are we working on it? Yeah. Is it going to take a little bit of time? It will. Right. If totally different modulus elasticity with zirconia versus titanium. And you've got something that, stress test gets real high and then boom, it just fractures. Whereas you see something in titanium, it's stress and then it just starts to bend.
It can bend,
right? Totally different. So I mean, I think it's got its place. Certainly aesthetic zone. That's an easy one. That was what everybody anticipated was, I'm going to put in a white implant, the white metal of the industry, if you will, right? I'm going to put a white abutment on it and it's going to look great under even thin tissue. But the benefit, the surprise, the thing that kind of opened my eyes, I'm like, oh, look at this thing. We're still inserting these and saying, stop at 50, right? That's pretty dang high for a 2-piece zirconia implant. You asked me 18, 20 years ago, we were making 1-piece zirconia implants and that was it. That was your only option. So it was like literally put this thing in, carve it up a little bit. And then think about it. I got this one implant sitting here, maybe a bicuspid, and I've got this 1-piece in. All this other stuff happens in my mouth over years, and there's all these changes, things come out, things in. And now I've got this one thing that's just a 1-piece pole. I'm stuck. What if I need to go back and reduce more bone and go in and do an all-on-4 on somebody? This thing's like in the way at that point. And those are brutal to get out if you had to. So the quick, short, and easy for me is, we've come a long way. 2-piece. There's a limited amount of options restoratively. They know or think that, we're going to invest more research or time to develop this thing. They're going to try and get into full arch with zirconia. I personally, I'm not as much of a fan. Everybody's going to be mad at me when they see this and be like, what's he talking about? He's not a fan. I'm not. Sorry. I know it's more popular in other places around the world. Just not here. Titanium works really well.
I feel like it'd be easier to make a titanium implant white than it would be to make zirconia work.
Yeah. Yeah,
I
or,
know.
Garmin has like a rock solid, right? It's got a little bit
Yeah.
of the mixture. So,
Sure. Yeah. Yeah.
yeah.
Yeah.
Yeah,
For sure.
spray paint it right before you put it in. Just
Yeah.
right on it and fire it in.
Yeah.
It'll dry.
All right,
Make sure,
so
make sure it's
so
ionized.
we're not getting infinity torque on our Zirconia pterygoid implants.
Oh, God.
Of course.
Downshift.
Yeah. So
Hold up on that.
something else I'm curious about too, when we go beyond the implant itself, just the screw, there's all the componentry that comes along with that, right? There's drivers, there's our prosthetic wrenches, there's all these different abutments and things like that.
Mhm.
There's the design of the MUA, of course. I mean, I've definitely seen a lot of different things and had different experiences with different MUA designs. One thing that struck me initially when we switched to NeoDent was the driver, right? So I was very used to using, say just a 1.2 millimeter, hex driver for virtually everything. But if you look at a Strawman driver, it's total, or Neo driver, it's totally different. Why is that? What are the advantages? Tell us about that a little bit.
Yeah, I love that. I love where we're going with this because the Neo driver, probably can't see it in here with my camera, but you can kind of see how it's like a cog on a wheel, right?
Yeah. Yeah.
I love this configuration. It's a star, but really, really important. If you have a star that's rounded, it's like your kid in kindergarten making a turkey, right? They take the pen and they draw the head, and then there's the feathers on the back. So that's a rounded edge. Same with a hex. If you apply too much force to a hex, it's almost a fail-safe that you have a hex round over time or wear, right? Because you don't want to insert with torque too high. And then, so that's that balance where people are like, my driver's stripped. Well, maybe you were torquing too much. We don't want you to do that, right? So it does get a little bit dangerous in that sense because this guy is awesome. I mean, it has this intimate fit. It's got these 90-degree turns on like I said, like a cog on a wheel. So the intimacy of the fit is nice. An added benefit that I didn't realize is when you go to grab your healing abutments, right, or any kind of screw that you want to drop in or grab from across the room, it does have a really nice bite. Either thing, right? Because it's not even a tapered aspect to it. It's just a flat-on cog to grab this thing. And now we're only asking you to torque our stuff to 20. Again, because of a Morris taper.
Yeah.
It's like, I think it's a beautiful thing or benefit for us. But, you just got to make sure that with any driver, you got to make sure that you're not here, but that you're all the way down. Make sure you're down and in that healing abutment when you're going to back it off.
Right.
That goes for any driver. So,
yeah, of course.
Yeah.
And
wait, because, and I'm sorry, I just thought of one other thing.
Yeah.
Though we're talking about these different connections, a 2.9, a helix short, the GM helix, right? You talk about a helix long, you talk about a zygo, all of those different, even though they're different connections, guess what they use? Same
driver.
One
Yeah.
driver.
Yeah. Pretty sweet.
I love that part of this thing. So anyway, really good question. Sorry. Go ahead.
Yeah. Another thing that struck me when we first started using it. So an implant company that we were using prior, the implant driver. So when I would go to pick up an implant and I'd go to be putting in the mouth, every so often, I just have like a really loose fit in the implant. And I had very poor control over that. And I was always concerned about dropping an implant, especially if it's like a pterygoid or something like that. But I noticed that with NeoDent, and I'm not entirely sure why. I'm curious about why this might be. Whenever I pick up an implant, it really it sticks on it, pretty well.
Yeah.
I'm curious about what's different there. Why might that vary between implant companies?
Oh, that's fun. You're tapping into stuff I do, like the Wizard of Oz behind the curtain. So I personally saw 2 years ago, I saw that our stab and grab feature on our latch-type driver, you have to use the latch-type driver to take it from the package to the mouth, right? Because the stab and grab feature, we want to really lock into the friction fit of the Morris taper, make sure that we hold the implant. We don't want it falling off. Okay. And so when we were doing that, we had these yellow wings or tips, if you will, to help grab it. And they kind of splay inside the implant into the hex to hold it. Well, sometimes, unfortunately, people switch from another system to us. They want to crank the motor up and they want to really put a lot of force on this driver. It's a latch type down inside a 3.0 platform of a Morris taper, right? And I'm worried that they're trying to crank the heck out of the implant and snap the implant off. That's my fear.
You
So
bet,
tell
man.
everybody, I'm like, please, I don't have to do this with other. I'm like, please, just let me give you the why. Let me tell you about Morris taper. Let me tell you about 3.0 platform. Let me tell you about the thing I don't want you to do. I don't want you to snap that thing off. I'm not worried about you torquing high, low, whatever. I'm asking you to do one thing a little bit, maybe different from your other system. Get the latch type driver to your implant. Take it from the package to the mouth. Set your motor at 30.
Okay.
Quits. Call it quits. I don't care how much or how little the implant is in the bone. Take the latch type driver out and go ham on your torque wrench.
Hmm.
Take that baby and now physically give yourself the tactile sensor feel. Let your head register even more data, right? That you're doing it by hand versus just letting the machine crank on a pedal with a motor. I think it's just better anyway. Take your time. It's not a race. And then ratchet that thing in with your torque wrench, and you're just doing this the whole way. Oh, I feel it. Yep, it's getting tighter. Oh, that thing's ramping up on me. Right
Yeah.
now, when you're in our torque wrench implant driver,
Right.
that won't hold it from the package. That's by
Right.
design. We did that on purpose.
I
Like
see.
literally, you guys, this is awesome. I literally have prototypes from Brazil sent to me for new torque wrench drivers that just
Oh,
have
cool.
a little bit more strength, but like, you know, they like send me these cool little things that we're constantly trying to enhance. So anyhow, those are meant for a quick connect, disconnect.
Yeah.
Right. And so we want that to get things in and out of the mouth easier when you're wrenching by hand. Right. But the latch type, slow your
30.
roll, knock her down to 30 if you can, please. And just
Yeah.
take it in wherever it's at. Call it quits, take out that latch type driver and go manually. That's my strong suggestion.
And I've noticed too that on a lot of the NeoDent implant drivers, at least the contra-ankle drivers, they have this little kind of I don't, for lack of a better word, a little nipple on the end of it. Like there's this little tiny protuberance there. What is its purpose? And I'm curious. I mean, that seems very fragile. Like it could just break off. And I think I've heard of that happening. Like why is that there?
That was there, like you see in automotive or mechanics, where you have like kind of a guide. That's all that was.
Oh, it just indexes it. Yeah.
To help bring you in and help you get you seated more easily down into the hex.
I see.
Right. And so when we made that tolerance a little bit too tight between the two, I got nervous. And
Yeah.
so part of a redesign that we did was to just kind of narrow that up a little bit.
Okay.
Right? And so we've gone through iterations of change in design within that driver, and like even still doing it today. We're constantly trying to figure out how to hit this sweet spot and make everything easier for you guys to use or handle. Right.
Absolutely. Yeah. And I've noticed too, another thing that I really love about the NeoDent multi-units, and this, this is a thing that used to come up for me all the time. Because when I first started using, started doing full arch, like I alluded to before, I was using high Austin. Soren and I both were for a while.
Sure.
And they had, their multi-units were a lot thicker and they a lot more bulky. Yeah. So you're showing those of us just listening to the audio. So he's showing us what the NeoDent MUA looks like. And it's a lot sleeker, a lot sexier. And I personally, when I'm placing, I'm not having to do bone profiling probably like 90% of the time, because it just curves out from that platform and avoids really impinging on the bone more often than not. Is that something that, is that kind of universal among like other full arch indicated implant systems, or is that more just like a NeoDent feature? What's kind of your take on that?
I think it's a really smart design. I came up with that. I wish I could say I did. I didn't. But I mean, if you think about, again, some folks can't see this because they may not be in, but when you're tipping your implants or angling, then the distal aspect of your implant's obviously down. It's going to be subcrestal, even if on the mesial aspect, you're just at crestal level bone, right? And so that was key or critical, especially, let me turn this guy around. So when you can get this guy in and it slips past that bone, like you were saying. And it used to drive me nuts. The place I used to work before that had a bulkier, wider multi-unit that we would false seats. Yeah, that's annoying because you're torquing it down. tactile, you're feeling your screw get tight. You're looking on an x-ray. You're like, it looks like it sounds good. And then you wait a couple months and all of a sudden you've got bone remodeling and all of a sudden things are loose, they're moving and breaking. And then you got to blow your schedule and slide them in, fit them somewhere. You guys know the deal. Pain in the butt. But,
Very well.
I mean, not even that, but besides breaking and fixing, now you got to go back and reposition. So when you're repositioning one of your multis, that means I've got to take all my records again. I got to start scratch basically, right? So yeah, I love this. And, you know, we still do have, just making sure everybody knows, we still have a bone profiler. We still have a little guide. There's still times that you're, you know, full mouth extractions, reducing bone, you're still cutting across extraction sites and you might be hung up somewhere. So take the extra minute
Especially,
and get that, you know, get that profiler if you need it.
I was gonna say, especially like FP1s, you know, stuff like that, where you're finessing in a very narrow area. We definitely got to kind of deal with that.
Yeah, really good point.
Why? So getting into MUAs, right? I think before NeoDent had a 45 degree, right? And then they made a 45 degree short.
Slim. Yeah,
slim.
Yeah.
But it is shorter, correct? It's a little bit. Is it shorter or is it the same height?
It does, but it's really the intent behind the design is to think about placement. Are you more, let's say, palatal, or are you right along the ridge? And then where is access to that screw? So when you had something that had that big long turn on the regular 45, right, you might have had to actually excise or cut a little bit of tissue back, right? So you got to numb the patient to actually gain access to this thing if you needed to switch out your abutment versus right over top of the driver that was used to place the implant. Your multi-unit goes in, and now the head of that screw that is locking down the abutment screw of the MUA is right over top of where that implant is, right? So it might be a little bit of a better fit and just angulation. So this is one of those things that's a challenge for me to kind of charade with you over a podcast without showing for both, right? And it's really, like you guys said, it's about where is placement of the implant in the arch.
You know, we bring up an interesting modality, right? So you talk about FP1, we're obviously talking about MUA. So right now we're starting to see a little bit of a wave of fixture. And we're starting to see that get emphasized a little bit more.
Yeah.
And obviously we used to do that, you know, I mean, back in the day, right? With the sort of initial parts of full arch before we ever had multi-unit abutments. Why have we started coming back to that? What are some of the pros and cons? How should people be considering that?
Man, really good questions. You guys don't mess around. If we try. So I mean, it made sense, right? It was like shorten up how much of the abutment goes in to the implant and have it sit on the platform of the implant, right? So now if you've got an abutment resting right on the top of that implant, unfortunately, we've got a butt joint. You've got a flat on flat. Well, guess what that means? You got a gap. Bacteria can get in between there. Yeah. Looks great for surgery. Looks great the day you put the thing in and everything. But what's it look like down the road? You're definitely going to have remodeling, at least on a full arch. You're going to have remodeling around where those implants are, unfortunately. Right? So we're back to Morse tapers, you know, subcrestal, emergence, back to all these other things. And then we were utilizing an MUA. So we don't care where that implant is in relation to bone, and we can always adjust by the height of our MUAs as well when we're talking about design. But we've kind of gone back to an FP1 because we said, man, what if it's like younger patient? What if they actually have bone? We don't have to mow down or knock down 4, 5, 6 millimeters bone in this younger patient, right? And so, so we're dabbling. We're kind of back and looking at it again and saying, can we do this? Can we put something in at the implant level, right? Can we span a full arch? Can we maybe print, or can we mill something that's going to fit? Honestly, my opinion, guys, and I'm nobody, but the jury is not out on this stuff yet. It's not here. I mean, the problem, it's a good problem to have, but that Morse taper connection how tight that tolerance is we're talking about inside that cone. The give and take is, man, I got great bone maintenance. I've got no movement. I got no screws loosening or breaking. I've got all these benefits to this thing. But the one thing it doesn't do really well is I can't go implant level, and I can't span a full arch with implants that are divergent, convergent, they're along the arch, they're this way, they're that way. I just can't do it. I can't go at the implant level. That's where the MUA saves us everything. I don't care what direction you put these implants in. Where in the head, I don't care. You get me an MUA, especially with all these different options we have today, a 52.5, a 60, like all this. Just get me as close to parallel as possible on my MUAs, path of draw. Passivity of fit is key. That's key in full arch.
I'm curious about something as well. So the increments of multi-units have always seemed a little bit random to me, like 17, 30, 52 and a half, 60. Like, why are they that way?
Because it's another really, I'm telling you, man, you guys are locked loaded here. You're like grooving.
Yeah.
So I'm showing this picture to you guys because one, just the top of the MUA alone, 30 degrees convergent, divergent, right?
Yes.
You've already got that just in this cone on the top.
Yes.
But then when you talk about a straight, a 17, a 30, a 45, a 50, when you're talking about that, you're talking about lifting this up and rotating it to the next position of your hex.
Yes.
Right? And so now I'm in this direction. So between the two, there's no need. There's no need to go in and split hairs and say, oh, you know what? We got a straight and we got a 17. Why don't we have like a 8.5?
Yeah.
We don't need it. We don't need to split hairs on something. And you see that there's obviously many of the companies out there today that offer 17s and 30s, right? And so now it's just a matter of where is this implant and bone? How high is that angle, or where is it,
right
in the mouth that we need to worry about zygos and pterygoids and back to parallel. Let's get as close as we can to parallel, and we've still got 30 degrees from the top of one multi to the next.
Yeah, and I'm curious if you've come across, and this is fairly recent. I think I saw it maybe the first time, maybe as much as a year ago. I think it's Brandon Crawford, same guy that did.
Implant face off.
Yeah, exactly. Yes,
but that recently, yeah.
Right, he's the inventor of the smart pickup system, right? And more recently, they've come out with a multi-unit that can be, you can loosen it and actually have infinite configuration and retighten it wherever you want it.
Yeah, lock it down.
Yeah, do you have any concerns about that, or do you think that would, that might be something really useful? Or
I think it's really cool. Kofort's a really smart guy.
Definitely.
To just push all of us. You need people out there to do this, right? To get out in front of it and constantly challenge us to see what's better. Do I have my reserves? Yeah, because I'm like, what happens if that thing comes loose? What's the fail safe? So, I mean, I looked at it and I did a little bit of research on it. I think it's really cool. But and a perfect example of this is not too long ago, we even did this. We came out with a multi-unit abutment, and you can see this guy has a hex at the bottom so that we lock it into the hex for engagement. Well, not too long ago, we did a non-engaging angled multi-unit abutment. I mean, I had to clean up a ton of old cases with folks where things got loose, right?
Yeah, there's just nothing indexing.
And you're like, how do I go? So there's ways to work backwards and reverse engineer it, but it's a pain in the rear, and you don't have that problem today. Here's a perfect example again. You don't have a problem with this today with an MUA because, there's a 17-degree abutment. The abutment screws here. It follows the same axis of the implant, right?
Right, yeah.
For the angle, I put a prosthetic screw on the top in a completely different angle. Can't tell you how many times I've got a rep or doctor calling me and they say, this never happened to you two, I'm sure, but they broke the prosthetic screw.
Oh, never heard of it.
Popped, right? And they're like, what do I do now? And I'm telling everybody, I'm like, just go back in and take this abutment completely out.
Every time.
Right? Just put a brand new MUA in, right? And
First, what I have to do is I have to screw around with that cotton tip trick and
Oh, you
swirl that around on top of it. And actually screw it and create the whole damn abutment.
Did you get
I try
any?
to do every time. That's my process. It's happened twice. I've gotten it twice.
You got two? That's cool.
It's worked like 2 times.
Nice. Yeah.
I was actually thinking about this earlier and I was waiting for the time to bring it up. But what is or do you have any special tools or recommendations for when you do break a screw off in the implant? Because I know they make screw retrieval kits, right? Where you put a little pilot in and then you take the reverse torque into the screw and try to get it out. I've had very poor experiences with those, and I end up, most of the time just taking the implant out, putting a new one, calling it a day.
Yeah.
But do you know of any good techniques for that, or is that kind of the main one that you've heard of?
It sounds like your special tool is the trephine.
Yeah.
Yes.
Right?
That's
That's the one.
unfortunately, but I would love to avoid the trephine if I could find a magic solution to taking off a screw that's cold welded inside of an implant, and I'm kind of like SOL.
Yeah. Oh, that's too funny. We do have a service set. So we do have something that people can call regulatory, give us a little bit of information. We send out the parts, right? And then there's a PDF that tells you step by step. And, at first glance, it may seem tedious or cumbersome or complex or whatever, but it's just broken down into bite-sized pieces. How do you eat an elephant? One bite at a time. It's like, what is your problem? Let's find the right part of this PDF. And there's a lot of systems out there. I've looked at some other implant companies. They're all very similar. They put some type of cannulated tool down into the implant to just engage the top of the connection and lock this thing in. And typically, they center some kind of drill that will prep the middle of that fractured, let's say, abutment screw inside your implant, right? And then they'll create some type of device that's like an in-out screw they use in mechanics. The threads are reversed. So they'll either use that tool or they'll tell you to freehand, but they're all very similar. So Salvin has something, they're like everything but the implant. They've got their own kit. I've seen Hyacinth offer something that actually helps with other implant systems. So they all have something, right? But it is pretty cool. It's funny you brought that up because I'm not kidding. I'm in the lab with my buddy, my mentor, Dr. Alex Molinari from NeoDent. He's our director of clinical, and we literally go down into the laboratory and we are messing with burrs and we're deforming. We're trying to literally weaken screws so that we snap or break them off inside implants. And then we literally take these service sets, these different tools and pieces, and we test them. So here in our little lab. So there's another glimpse in our world.
So NeoDent has one of those sets that you can use to.
Oh yeah.
Sure. Okay.
Have it for the 2.9, the Helix short, the regular GM, the ZI. Yeah. I mean, it's typical protocol for us. The amount of time and effort that is spent looking at the system from a comprehensive perspective is we've got to have everything for you guys, and unfortunately, I'm going to say it again. I'm going to say it one more time. We've been doing this for an hour and 18 minutes. You guys are getting sick of hearing me.
Not at all.
And one more time though. I get so many calls about a third party part. It drives me nuts, right? Just send me an x-ray. Let me see. I mean, I'm telling you, it has to be precise. We're talking about CNC, automated manufacturing, mass production inside these, these facilities, but it's our manufacturing spec. And if it's a Morris taper, you're talking about stack tolerances. So when I get these x-rays, I see lucency between the abutment and the implant. And I'm going to have a little bit of movement in there. You saved $4. The screw snapped. And now I'm trying to use my service set and spend my time helping you with a part that's not mine.
So we actually had that question on our sheet about what your thoughts are on using non-OEM parts. Now it sounds like
Never made it. There you go. I got to take my blood pressure medicine.
Yes, it's not smart to do. It's worth the extra fee.
It's not. I mean, you're talking about. We just said a cone. It's 18 degrees or less. So we're talking about 16. we're talking about how intimate this fit is between the abutment coming down into that implant and locking up, right? That's critical, right? And so they're not chincing on this type of connection. We talk about manufacturing specs in aerospace, or another big one is watchmaking, right?
Yeah.
Thinking about the precision that has to go into making these tools. So other than those two industries, dental implants is the next one where it's so important on the precision manufacturing. And some of these third-party companies, they're hitting an ISO standard, but I have no idea what their machine is really capable of. So if I get super nerdy, sorry, I'm gonna apologize ahead of time. But when you talk about a margin of error that maybe goes out to the centesimal, right? A 0.015 versus millesimal, a 0.015 versus a 0.15, right?
Yeah, right.
Huge difference in your part, right? When you take that out an extra decimal point, right? And so it gets scary to me that somebody says, oh, let me get some part from whoever the manufacturer is. In this case, we'll say NeoDent. I'm going to take this part. I'm going to send it to China. I'm going to have somebody try and scan it. Now I know it's not as good. Whatever part they took from me, it's got its own SKU. Whatever my manufacturing spec is, if I stay with an ISO standard, I can be a little bit bigger in the manufacturing line or a little bit smaller on the part.
Level tolerance.
When part comes off my manufacturing line is not the actual spec, probably, right?
Yeah.
And now you send that to somebody else. They take basically like an impression or digital impression of it. It's not going to be as good. And now they're going to put on their machine, which might not be as good as my machine, right? From a precision. And now it's going to make it, and it's going to now take this imperfect part and make it off the line bigger or smaller. And we're talking about just the abutment. We're not talking about the implant and the manufacturing of that has its own margin of error, right? And so all you're doing, your stack tolerance is getting worse. It's getting worse. And so hopefully I've confused the hell out of everybody that might listen to this thing, or they might just appreciate the amount of time and effort that goes into the precision of making the parts. And when you're off inside a Morse taper, you're going to see problems.
Yeah, no, I think you make your point well. I mean, it's compounding errors and something that has to be very precise in order to function. And when it does really well. But if you're off on those tolerances at all, the whole thing just kind of falls apart.
Whole thing's out of whack. Yep.
Yeah. You talk a lot about, you kind of talk in terms of, CNC machining and tolerances and things like that. We actually had the privilege of going down to Curitiba last year, and we went to the NeoDent factory. So we were able to see everyone working there. I mean, it really was a sight to behold. I mean, it's just such a large facility. They're also building another one, which is like 2 or 3 times as large, one of the largest manufacturing facilities in the world. It's freaking huge.
The third one.
So there's third.
This will be the third one that this will be a third location down there, massive. And it's funny you guys said that. I'm actually, I'm not kidding. I'm literally going down on the 20th, which is my birthday. I turned 50, but I'm literally getting on a plane, leaving my family. I'm gonna travel down on the 20th of April, and we're doing this really cool marketing event down there. So I'm literally going to be down and see all that stuff you guys are talking about myself. 22nd to 24th. And I just booked my flights today. Yeah.
Oh, fantastic.
Cool. Yeah.
Well, for your birthday, please go to Ichigo Ichi, I think it's called. It was some of the best sushi. And I go to, Tyler and I, we love to hit up our Nobu and stuff when we're in Vegas. Yeah. But man, that restaurant was unbelievably good. If you want, I'll send you the name after. So if you like sushi,
yes,
you could go.
Please.
And
I would love that.
So good.
Yeah.
It's fantastic. Going off on a tangent, but it was awesome.
I love it. No, that's great. I'm excited. Yeah. And to your guys' point, when I'm down there, they're actually going to maybe steal me, pull me away, and I'm going to go see the innovation team. I'm going to see Dr. Sergio Bernardez. So, that was another interesting thing. I think you guys asked, like, what kind of time and effort do you put into this? I mean, Tomei, you mentioned Genome, but Tomei and Sergio Bernardez, I mean, those guys spend several days a week working on this new product development stuff. So
Yeah.
you talk about how cool is that, right? It's by a dentist for dentists. These guys did this because they saw an opportunity to help down there in South America. But I mean, to have these clinicians work in the labs and, and just product development itself is like, man, I want that job. That sounds kind of fun.
I mean, we saw Dr. Tomei. I mean, and I don't even want to know how much this guy is worth, right? Like he could be chilling on an island probably somewhere. And we went to the clinic and he's placing a new special implant that we can't talk about. So we'll avoid that. But placing some special implants, practicing. Oh yeah. We signed the NDAs we got, so I can't talk about it here. But it's so cool watching this dude who could be doing whatever he wants. He's still working on patients, perfecting implants, and he wants to do it himself. So he knows, by a dentist for a dentist to make sure that it works well for everybody.
Yeah.
We were really, really impressed by it.
Man, that is really cool. I mean, I am so happy for you guys that you got to experience that. That's like a A1 nerd bucket list. Check the box.
No,
right? You go see that stuff halfway around the world too, just making the trip. I mean,
it was a track test.
That's cool.
Tyler had a rough one, but
I sure did. And that's a whole nother story we're not going to get into. But, I think for us in that trip, the highlights were shaking Janino Tomei's hand and then seeing the factory, eating at Ichigo Ishi for the sushi, and then placing Zygos. I think that's pretty much
holy cow. Holy cow, what an order.
Yeah.
So, okay. All right. So you got to see some Zygos there too, huh?
Yeah. We were there to place them.
Amazing.
Yeah.
It was cool.
That was a really cool experience.
Oh man, I love that.
Briefly, I would like to kind of get into a little bit of some of those exotic techniques and some of the designs that are around that, right? So we've got I see you're pointing out our onion driver.
I literally had the purple onion in front of me sitting here. You're talking about Zygos. I thought that was too funny.
Yeah.
Everybody loves the handle on this thing.
Yeah,
anyway,
it's all.
I'm sorry.
No, not at all. So I'm curious to talk a little bit about, I think I've heard a rumor of a pterygoid implant coming out for NeoDent. We've got transnasals, transsinus, zygomatics. What are some of the intricacies that go into designing implants specifically for techniques?
I mean, we're probably the only company, again, to my knowledge, when you want to be the kings and queens, you got to have it all, right? And so they have 3 different kinds of zygo implants alone, right? You got a fully threaded, and my philosophy, again, my mentor is Alex Molinari and all those guys in that court that talk about an anatomical approach to the placement of an implant. Yeah. Get me the diagnostics, plan the work the plan. I love seeing 3D models so that people can dry run where they're shooting their implants and what type of anatomy is presented by the patient so that we can do a Zaga 0 to, Zaga 4, that kind of thing. And then it's whether you want a smooth implant or something fully threaded. Right. And so we have all of that, including, a more narrow zygo that's indicated for quad zygoma. Right. So now it's indication how much can you do and what can you do? We just talked earlier tonight about our Helix Long. We do have a pterygoid implant. Yay.
Yes.
It's here. It's indicated for it. You can do it. But yes, we are also coming out with a new pterygoid. Everybody's going to like the design. It's going to be, a little bit more of what everybody wants, a little bit more of an aggressive thread, a little bit more of a taper, a little bit more of a bite.
Sure.
Light. I don't know. We'll see. It might even have, some other features to it to match other things that people are looking for in the industry. But not giving away any secrets. That's the stuff, the expectations that everybody wants. And it'll be here next year, so we'll have the pterygoid. This is the kind of thing that happens. We've been working on this for a while. People think it's just made, it's done, and here you go. No, we went through over 133 iterations of our NeoConvert system alone, right? To come out with something to help you save time, do a conversion, the old school method of analog with a jump, make your holes smaller, keep your prosthesis stronger, but more importantly, keep you moving, like keep you moving quickly through the conversion process. I mean, that alone was fascinating to me. And then being a product manager, I get to see all of the rigorous studies, the stress tests, all the stuff that's done to make sure that the product will hold up over time. So, so back to Zygos, Terry's, all that. Lot of time vested in this, and you guys probably don't lie. You probably saw it while you were down there.
Maybe.
Maybe.
Yeah.
It was probably
neither confirm nor deny. But yeah, just to close out here, Cliff. So I'm curious, what we always ask a question somewhat akin to this. So in your world and the things that you pay the most attention to, what are you most excited about in terms of innovation when it comes to implants, prosthetics, all the things having to do with trauma and NeoDent? Where do you think the cutting edge is, and what should people be getting excited about?
True. It's another good one, because I'm feeling at the moment like we've just hit upon so many new products that we're starting to get into those really nitpicky nuances of what can I do next. And, this is somewhere else in the industry, but maybe it's how we can deliver an implant. Things like maybe even biomaterials. I heard there's it's a really cool company that has something that's excreted by mollusks or some type of food creature, right? Like a clam or something, right? They fire out they extrude some with calcium, and then it gets hard. So
it's
maybe
petronite stuff, right?
is that it? So
yeah, I think
imagine shooting something into a socket site and it sets up and gets really hard, then you fire your screw in, right? So maybe it's biomaterials, or maybe it's that next. I mean, honestly, for me, it's maybe that next digital piece that kind of ties in something a little bit better with your records. It's more so maybe the software, the soft tissue, the alignment of bone. I mean, people are doing all different parts and pieces or aspects of this, but somebody's going to tie it all in together, right?
Yeah, I think that's
No, for sure. And we get to we're lucky enough to get to talk to people all over our industry that see these things, and you're spot on. Like, in my opinion, after talking to a lot of people, that's where we're going to see a lot of innovation, is CT segmentation that is going to offer better prosthetics, better alignment, a mesh system of guided, which is like, everything's aligned properly so that implant goes exactly where you want it.
Yeah.
And then maybe you can even have a zirconia prosthetic that is ready to go, that just sits on top of those implants, and you're done, and it's perfect passive fit. That stuff's coming, it's coming quick. And, even in the last, 5 years, we've seen so many crazy things with photogrammetry, people printing cases same day. And before you know it, there's going to be materials out there that we print, and they're just as strong as zirconia, and the patient's done and ready to go. So it's an exciting time to be here, as long as there's no companies out there that start offering $4,000 all on fours,
Yeah, don't do that. We're not there yet.
Yeah, please don't.
Obviously, here's the best part. We're pushing ourselves. You guys are asking about innovation. Where do we go next? And the best part is, on the other end of this, which people forget about all the time, is there's a human being. They're going to get better treatment, right?
100%.
That's key.
Right.
Like, the best part of the whole gig is, man, we're just going to help people even more. I'm excited. Where am I going next?
You got it. Well, Cliff, we really appreciate you, taking some time out of your day to talk about, what you do on a day-to-day basis. And, personally, I feel like we've been very enlightened with all the, intricacies of implant design, componentry, all that. It certainly answered a lot of questions for me. And, I hope that our audience gets some value out of that, because I think that, we talk so much about surgery and techniques and how we do this and that. But, really what it comes down to, our success is built off the innovation and the products that we're putting in people's mouths. And it's just so it's so reassuring, for us to know just all of the engineering and all the research that's gone into, the systems that we choose to use. And so we really appreciate your part in that.
Yeah. Oh my gosh. Thanks so much. Really had a blast, man. I'm I'm surprised we went this long. My apologies. I had fun.
I'm
Appreciate
not
it.
surprised at all. You brought a
Perfect.
wealth of
People will love
information
it.
to the table. So yeah, thank you so much.
Thanks, guys. Appreciate you.
Take care.
All right.
All right. See you.